From data shown, we could observe the usage of plastic specifically has increased gradually since the consumption of single-use plastic is higher than ever. This could be proved when numerous tons of plastic is clearly seen at every edge of the world. This has been the major contributors to the pollution, since all know that plastic is a non-biodegradable substance despite high costs required. On the other hand, the increase in the quantity of plastic not only will affect those marine animals, but it will harm the whole population. To be exact, in Thailand, whales are under constant threat and they have also been hunted to the point of extinction thanks to our greed. For an instance, back in June 2018, 40 kilograms of plastic were found inside the stomach of a whale, which led to death. Therefore, we choose our product with equal thought that the creation of the sea must align with the fundamental rules wherein it must be sustainable in nature and eco-friendly to the environment. Hence, Travioca is the answer to the equation. Travioca derived from the combination of the word trava, which means grass in Russian, and tapioca. Travioca is a composite material with fiber of grass as strengthening substance and tapioca starch as metric substance.
To make it clear, Travioca has four main objectives. Firstly, Travioca can save lots of money since the ingredients used are affordable and it has been clearly proved throughout the experiment. Second, Travioca as expected could be easily substitute the role of almost product, especially plastics. This could be used for daily wears like food container and parcel wrap. Next, as our main purpose here, of course Travioca is an innovation which lead to zero pollution, which this could be benefits many. Lastly, Travioca is a biodegradable substance since it is mainly made up of organic material without any chemical added. This will shorten the period of decomposition of Travioca.
Disclaimer: all experiments were conducted at home during MCO period. For the first experiment, we are going to determine the production of material. Firstly, we need to prepare our material used, which is grass. For this time being, I'm using micro Liyana grass as my type of material. Secondly, we need to rinse our material prepared with water. Next, we need to boil the grass and add 250 grams of sodium hydroxide into the mixture. After 10 minutes, we could see a huge difference in our mixture, such as the presence of bubble and the color of the solution. Next, we need to rinse the previously boiled grass with cold water to neutralize the pH value of the material. In the fifth step, we are going to mix sample A by putting half of the boiled grass into the blender and blend it. After that, we need to put the paste of the sample A on a mold and shape it according to the shape of the mold. Then, leave the fiber under the exposure of sunlight until it getting dry. Furthermore, we are going to make the sample B by heating the blended excess paste together with water and add 2 spoons of tapioca starch. Lastly, repeat step 7 and 8. Here is the result of the experiment. For the second experiment, we are going to determine the durability of each sample. From the data above, we could see sample B, which has tapioca in it, has better strength compared to sample A. In conclusion, the presence of starch in the material influenced the rate of the durability. Last but not least, we are going to compare the rate of decomposition. In brief, we could see that our material sample A and sample B could be decomposed in just 2 days. Meanwhile, plastic did not show any changes even after 7 days. As consequence, it proved that our material sample A and sample B are biodegradable. All things considered, that sample B is the most ideal material for our product, Travioca.
Next, let's break down the significance of our procedures. First and foremost, we carried out fiber treatment to remove the coating of hemicellulose and lignin to only obtain the cellulose of the grass. To do so, that's why we boil the grass in lye and grind them in the blender. It is to reduce the content of non-cellulosic binding material. Now that cellulose fibers are obtained, hydrogen bond can be formed between the molecules in cellulose. Hydrogen bond is important to provide mechanical strength and chemical stability that causes our product to be durable. It also leaves the melting and boiling point of our product, since more heat energy is needed to overcome the forces of attraction between the cellulose molecule and automatically increase the rate of insolubility in water. These properties are important to ensure that Travioca is as compatible as plastic packaging. Next, sodium hydroxide also functions in reducing the hydrophilic property of fiber by reacting with hydroxyl group in cellulose. Besides, it also helps to increase the pH of fibers that causes the fibers to smoothen and swell before the grinding process. It can also improve the mechanical property of Travioca by increasing the content of cellulose in fiber. As the binder of our product, we choose tapioca starch as it has high viscosity property, which is important to give a firm shape and texture to Travioca. Tapioca starch also helps in increasing the strength and smoothness of Travioca to make it a product that can be competed in the market. It also has a high melting point that will prevent Travioca from melting or becoming sticky due to the hot weather.
As we are using tapioca starch in the production of Travioca, gelatinization will occur when being heated in the presence of water. When treated with hot water, tapioca starch turns into a thick paste. As a result, it will fill up the porous surface of material as the strong bond is formed between the fiber and the tapioca starch, which provide a higher mechanical strength to Travioca. It happens as the starch granules start losing their orderliness due to the increasing temperature and swell from large amount of water moving in and becomes trapped in the swollen granules, causing the liquid to thicken. As we can see, it only costs 6 cents for each 1.5 meter square of our product.
Finally, the future improvisation of Travioca is to have an addition of substance that is able to decolorize Travioca. Since Travioca is a raw product, the product will have a hint of brown color. Therefore, the substance is used to remove the brown color and produce a white product. We would also like to include nanogrind technology, which is available in UTM screw die. Nanogrind technology is the process of making small particles even more compact to produce a new product. Next, our hopes for Travioca is to reduce the amount of pollution in the world by encouraging the society to use an environmental friendly product. We also hope to be an inspiration for young developers to continue their journey in developing products to help save the earth. Lastly, we hope that Travioca will be able to provide a better environment for the future and the current generation.